Today we are going to start with a new chapter, which is determinants and matrices. Now this is a pretty easy chapter, but it forms the basis of a large number of chapters in mathematics. The first question which we have is, we need to find the value of this given determinant. For solving this question, one important thing we should know is that we should not always do the expansion thing in determinants, but what we can do over here is, for solving this problem, we can split this determinant as a sum of two other determinants. We can write this determinant as a sum of 1 a square, a cube. As we can see that the fourth column over here is written as a sum of two different terms. So we can split the given determinant as 1 a square, a cube, and similarly the other terms, which are 1 b square, b cube, 1 c square, c cube, and 1 d square, d cube, plus 1 a square and the second term, similarly 1 b square, the second term, and so on. Now what we need to do, we should concentrate on the second determinant. Let us write this determinant 2 as 1 a square, bcd, 1 b square, cda, 1 c square, dab, and 1 d square, abc. Now what we can see that in the fourth column, in each of the term, one of the terms out of a, b, c and d is missing. So what we can do is, we can multiply the first row by a, the second by b, the third by c, and the fourth by d. Because the term a is missing in the bcd term of the fourth column, the b term is missing over here, the c term is missing over here, and d is missing over here. So we can multiply this by a, this by b, this by c, and this by d. So the value of determinant 2, in order to keep the value of determinant 2 same, we have to divide it by abcd. So now this becomes a square, a cube, and abcd. Since we have multiplied the first row by a, similarly multiplying the second row by b, this becomes b square, b cube, abcd, c square, c cube, abcd, and d square, d cube, abcd. Now what we can do is, we can take the term abcd common from the fourth column. When it comes out, it gets cancelled out with this abcd to make the value of determinant 2 as, this abcd gets cancelled out with this abcd and the value becomes a square, a cube, 1 b square, b cube, 1 c square, c cube, and 1, and d square, d cube, and 1. Our determinant 1 was 1 a square, a cube, and similarly the other three rows. Now we can see that determinant 2 can be converted into determinant 1 by interchanging three of the columns. We can interchange these two columns, then we can interchange the next two columns, and then the next two, so that we can interchange three columns of determinant 2 to get determinant 1. So this becomes minus 1 power, since we have interchanged three columns, power 3 times determinant 1, which is equal to minus determinant 1, and hence the value of determinant 2 plus determinant 1 is 0, which is the value of our initial determinant. Hence what we learned in this question is, we need not do the expansion thing always in the determinant questions. What we can do is, we can apply some of the theorems and some of the properties of determinants to get our answer, and our final answer in this case is, the value of the given determinant is 0.